In this section, we are going to cover engineered fill and earthwork. It's important to have safeguard during construction. CBC 1304 covers site work. Verify measures taken to avoid danger to life and property for excavation and fill work. Slope limits 1 to 2 max 50% unless otherwise permitted by soils report. Cannot negatively affect adjacent structure with surcharge from soil placement unless designed, excavation causing underpinning unless shoring is provided. Having said that, it's very important to be aware when there's excavation going on next to existing building, including trenching, and we'll cover those slides later. And you need to be aware of what damage could be done to the foundation if proper measures or safeguards not taken during construction. Part of engineered fill and earthwork is controlled low strength materials, short CLSM. IR 18-1 covers CLSM ranging from 50 psi to 1200 psi strength. CBC 1803A.5.9 requires geotechnical investigations for if you have low strength material. Pay attention to the approved specifications for the project, which may dictate subgrade preparation requirements, CLSM properties, mixed proportions, placing requirements, sampling, inspections, and test requirements. In short, this is the time you open your project specifications to see what geotechnical engineer had in mind and how architect or civil engineer placed engineered fill or requirements for control low strength materials. Also look at approved drawings that dictate locations and dimensions, how far to extend. CLSM is not considered to be concrete. It's just higher strength soil technically. In this video, if it's not playing on slide, please go to this slide and press play. As you can see, water truck is there to spray water on soil. Proper moisture in the soil is very important when compaction is being done on a fill. And it's not just under buildings. You have to make sure the whole site is prepared correctly as in the plans and specifications, because in the future buildings may come in and if it's not compacted or tested properly, then we'll have settlement problems down the roads. Grading, excavation, and fill will be covered in the next few slides. CBC 3304.1 covers organic material in excavation. Tree stumps and roots are to be removed to 12-inch depth. Any wood forms or stake within ground or between foundation sills and ground removed before building is occupied. I think it should be more meant before concrete is finished. From this slides you can see tree roots encroaching into excavation, and these should be removed away from the excavation, so when concrete is placed, these roots do not end up getting embedded in the concrete, and they'll cause corrosion over a long period. CBC section 1804A.1 states excavation for any purposes shall not reduce vertical or lateral support for a structure. Exception 2 in CBC 1804A.4, impervious surfaces, which is concrete or something more hard like concrete, shall be permitted to slope less than 2%. Normally 2% minimum is required. It's allowed to be less where the surface is a door landing or ramp that is required to comply with access sections stated here, 1010A15, 1012A3, or 1012A61. Obviously, CBC section 1804A.4 say slope ground 5% away from foundation, 2% if impervious material, which is concrete. So that's why the previous slide allows less than 2% at doors, because it's impossible to meet both requirements. CBC section 1804A5 are for grading and fill requirement, restriction in flood hazard area. So if your project's in a flood hazard area, it should say on the cover sheet of the plans. If it's in flood hazard area, many times it would be stated in the geohazard or geotechnical report, and pay attention to that and go to this section for the fill and grading requirements. CBC section 1809A.14 covers pipes and trenches. Trenches parallel to footings shall be below a plane having downward 1 to 2 slope starting 9 inch above bottom of footing, not closer than 18 inches. As you can see from the sketch, 18 inch minimum horizontal and vertical 9 inch above bottom of the footing. Any alternative must be accepted by the design professional responsible in charge and DSA. This sketch is very important. When you don't have anything in your plans, 1 to 2 slope, 9 inch above the footing, draw a line, any trench that goes below that, not permitted. Basically, you'll jeopardize capacity of footing if you do that. Anytime you see a trench next to a footing, existing footing, new footing, pick up the phone, talk to the design professional, say, what do you want to do here? Or look for standard detail in the plans. Looking at this slide, is very clear, bottom of the footing where is going to be, and the trench is much lower below the bottom of future footing. All the fill in the trench need to be compacted correctly so footing will have proper support, proper bearing material underneath. Now we'll talk about soil stabilization. Soil stabilization. There hasn't been many changes to code when it comes to soil stabilization. DSA does not use many of these systems when it comes to rock anchors or soil anchors very often, but it's still important to know about them. Reference standards are Post-Tensioning Institute, which is applicable to vertical anchoring, resisting overturning. You can see chapter 8 of PTI for testing and inspection requirements. Here are some code changes from CBC 1810A. 1810A.3521 and 1810A.3522 cast in place or grouted in place. Items shown here in red are the changes to the previous code. So cast in place along with grouting in place been changed. The next code change is 1810-3522, where again cast in place along with grouted in place, and it also changes 30 times the specified diameter. There are exceptions in the code, and specify has been added onto it. Code 1811A.3, some changes to the corrosion protection been done in this code cycle, such as was item 7, a minimum of class 2 corrosion protection is required for temporary anchor in place less than or equal to 2 years, and some strikeouts are shown here. Item A also indicate load shall not exceed 80% of specified minimum strength of tendons. That's a new item, and a maximum of 80%, which is 80%, 0.8 times, which is 80%. And then if the next one is 1812A2, shoring will be exposed to site condition for less than or equal to 2 years. 2 years been added instead from 1 year. Construction requirements for drilling and lagging, code section 1812A6 is for inspection, survey, monitoring, and observation requirements. If there's an adjacent structure, then code 812A7 to monitor adjacent structures, any soil movements affecting building within 100 feet or 3 times the excavation depth. Very important to understand. Code 1812A.8, tolerance for soldier piles and tiebacks. If your project have earth retaining shoring, DSA approval is required for the permanent shoring not replaced by building walls. Also, if any shoring next to DSA regulated building or where students are exposed, basically failure of the shoring could injure any student, that would also require to be approved by DSA. Any shoring to retain earth when it's not next to DSA regulated building or students are not affected does not require to be approved by DSA. Would be considered construction means and methods. Soil stabilization is also achieved using vibrostone columns. The ground improvement is done usually in geohazard report to mitigate liquefaction and reduce settlements. However, when we do that, it also increases bearing capacity of soils. So it sometimes gives you collateral benefit of increased bearing capacity when mitigating settlements and liquefaction. These are not considered deep piles. This is stone columns, and it usually not used for uplift capacity. Normally VSCs are installed over footprint of the building. These are not applicable to compacted aggregate piers installed under foundation elements only. CAPs are alternate design, but BSCs shall not be confused with CAPs. Some information about expansive soils. Some characteristics of expansive soils are plasticity index greater than 15, greater than 10% soil particle passing through number 200 sieve, more than 2% soil particles are less than 5 micrometers in size, expansion index greater than 20. Normally this is all evaluated by testing lab, so really don't have to worry a whole lot about it. Usually sites with expansive soils have special requirements. Many times design or geotechnical would call over excavation and replacement of fill with some stabilization treatment such as lime treatment. If you do have expansive soils at your job site, very important to pay attention to specifications. Look for a section on mixing. It normally requires 2-time mix before it's achieved, maybe more. So very carefully read the section on expansive soils and lime treatment or any treatment that's specified and how it should be achieved. And liquefiable soils have special requirements to mitigate liquefaction. Such project may require additional review by CGS after mitigation construction occurs. Just remember, foundation work cannot commence prior to CGS accepting results of mitigation work. DSA does treat these issues like deferred submittals many times. Check project drawings for these requirements, whether it's a deferred submittal or not, to help avoid stop work order. All requirements should be in your construction drawings or specifications, and make the contractor aware of such requirements ahead of time, so if the contractor had different plans, they can work on getting those approval prior to starting foundations.